Video, welcome to the second part of improper integrals. Okay, and so this is case 3 according to the first video. Okay, so we're going to deal with the problem involving case 3. Okay, so what if we wanted to evaluate the integral from negative infinity to positive infinity of dx over 1 plus x squared? Okay, well, how do we treat this? Well, again, notice that we're in an improper integral form. So what we do, we replace both infinities with b and take a limit. So this now becomes a limit as b approaches positive infinity of the integral from negative b to b of dx over 1 plus x squared. Okay. Now, this is where I'm drenching up all your Cal 1 stuff. Remember that we said that if our integral is symmetric, what we could actually do is that we could get rid of the negative, replace it with a 0, and do 2 times the integral because the integral is symmetric. And so this integral is also equal to the limit as b approaches positive infinity of 2 times the integral of 0 to b of dx over 1 plus x squared. 1 plus x squared. So this becomes 1 plus x squared. Okay, because the integral is symmetric. And so factoring out my 2, this now becomes 2 times the limit as b approaches positive infinity of the integral of 0 to b of dx over 1 plus x squared. Now we know this integral of this, that's tangent inverse. And so if I look at this, this now becomes 2 times the limit as b approaches positive infinity of tangent inverse of x evaluated from 0 to b. Okay. So now it's a simple of plugging in. So this becomes 2 times the limit as b approaches positive infinity of tangent inverse of b minus tangent inverse of 0. Okay. In this case, we know tangent inverse of 0 is 0, so we don't care about that. Our negative disappears. Now it becomes, well, what is the limit as the tangent line goes to infinity? Okay, so tangent inverse of positive infinity is actually pi over 2. So that's the line that we get. As tangent goes to infinity, it approaches that line pi over 2. And so we know the limit now becomes 2 times pi over 2. All these simplifying, then we get pi. Okay, so again, this one is maybe you've run across it, but maybe you've never thought of it like that before. But in fact, yeah, tangent inverse of positive infinity is actually pi over 2. And so this is how we deal with these integrals, and it's the same thing. Okay, it's the same thing for case 1, same thing with case 2, same thing with case 3. We're going to replace that with a b and take a limit.